The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dan DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Thursday, May 25th, 2023, and our volcanoes are not erupting, either one of them. Kilauea still looks ready to pop, heightened activity officially still from USGS, but we'll get into the exact details of that here coming up shortly. How are you doing today, Dane?
Well, doing good. Just, waiting for Pele to wake back up and we get another summit eruption. Kind of only a matter of time at this point.
Yeah, we've been saying that for weeks now, it seems like, but she just keeps taking her time, a little longer.
Whoever went long on this bet is completely winning right now. Because the line was way too early type of thing.
Well, it cycled up, and it had that first pump fake, then it had a second pump fake about last week, and we'll focus on that here this week.
All right. Sounds good.
Yeah, so unless you got anything else, I'll just jump right into it here.
I think that's it, yeah. If anybody has any questions, go ahead and throw them in the chat, and we'll try and get to them at the end.
Yeah, sounds good. Yeah, I'll be leading discussion in the chat as well, so mahalo, Dane. All right. So, this week's Hawaiian Volcano Summary is an image of Kilauea taken this past week. Clear summit conditions with a little bit of fog coming off of this hardened crater floor right in here. And according to the USGS, they put out a special status report this past Monday stating that while the volcano is not erupting, it is currently exhibiting signs of heightened unrest. No unusual activity along either the East Rift Zone or Southwest Rift Zone. Earthquake rates are elevated around a summit. That's the Kilauea summit region under Halemaʻumaʻu, and also the Namakani Paio campground area just northwest of the summit. Small flurries of earthquakes are occurring irregularly. Rates have increased over the past week, with more than 100 earthquakes recorded on Saturday, May 20th, including a magnitude 3.7 event felt in Hawaiian Volcano National Park and surrounding communities. Overall, inflation still continues. Inflation is higher than conditions preceding the January 5th, 2023 summit eruption. Gas emissions are still low, and here is the punchline summary of the status report. These observations indicate that magma is accumulating beneath the surface of Kilauea summit region. An eruption at Kilauea summit does not appear to be imminent, although heightened unrest suggests an eruption at Kilauea summit might be possible with little to no warning. So that's the long and short of it. We do have another update issued every day, but the one from today does state that yesterday there were over 80 events in that area of the summit. So it's down a little bit from over 100 to over 80. So it's still certainly elevated and heightened above normal, but down a little bit there. If we look at the rates for the last year, here we are. In the past month is this set of 4 to 5 lines here on the right. And this back here is at January 2023 buildup. So the eruption occurs right in there, the earthquake rates drop, but this is the level of heightened seismicity we had beforehand at around 600 earthquakes per week. And now we've exceeded 800 earthquakes per week, 600 for 4 times. We've exceeded 800 twice, and we've almost reached 1,000. This is the total value of the summit and the Pahala region combined. So this is not just a summit, it's a little bit bigger value than the numbers we reported to you guys from the reports. So certainly higher than before. And if we look at the earthquake rates, earthquakes here at the Kilauea summit, here are the magnitude 3s in the last week. So we had a sequence that began on the 20th with a 3.1 northwest of volcano, moving to a 3.7 east of Halemaʻumaʻu, and then back a couple hours later, a 3.2 northwest of Halemaʻumaʻu. So the whole summit's filling and it's pushing both northwest and northeast, it seems like, just showing that whole buildup underneath there. And if we look at the earthquake rates for the last month in more detail, here's earthquakes per day now. This is the 20th right here. Earthquake rates certainly ramped up to that highest level, but since then in the last few days have come back down again a little bit until yesterday where they kind of popped back up to this in this graph it says 100 earthquakes, but we heard from USGS it's 80 in the summit region in particular. So we'll see, we're a little bit lower than before. We did have this spike right here of earthquakes. Elevation, the earthquakes are still elevated, unrest, but not looking imminent at this point. Interestingly, when we had this spike of earthquakes and that group of 3, we had an interesting tooth-shaped signal on our ground tilt. But otherwise, the story of ground tilt has been one of steady inflation for the whole last month, from -8 to +6 microradians. 14 microradians is a huge amount for it to be going steady, and that's really the prequel for it to pop with very little ramp up in the end. So that's the story here on Kilauea. Not a whole lot of change on Mauna Loa, and that's our Hawaiian Volcano summary for the week. So let me get us going here on the monitoring. Oh, let's turn to some more. Let's look at the earthquakes in a little more detail first. So let me pull up the earthquakes and show you guys. Oh, here's all the earthquakes in the Pacific Basin. Let's zoom it in a little more. So this is all earthquakes in the past week. You can see that we have our cluster in Hawaii Island and the usual spots, our background events surrounding the volcanoes, the deep source of magma through the lower crust there from the Pahala region, and then a few events here on Mauna Loa and some here on Kilauea as well. So that was a sequence I pointed out, the northwest, northeast, northwest. There have been, let's look at the settings here. Let me put it back to the last 30 days and look at all at 2.5 and graders. So you can see there have been quite a lot of larger earthquakes, these 2.5s that are showing that larger movement of area on the ground when an earthquake's rupturing. And you see they're clustered here in this northwest area. There's some right in that caldera area, but then otherwise you see, I find this pretty interesting if you look here a little more closely. This fault line right here is that outer caldera surface trace. It goes right through there. And we seem to have earthquakes lining up along that. We have our inner caldera going right along here. We have earthquakes looking like they're lining up close to that as well. There is some error in here, of course. But overall, it just does seem like it's pushing from below and just popping everything up and outwards. This cluster that occurs here to the northwest is not unlike what we saw in Mauna Loa last year in the build-up to Mauna Loa's eruption. We saw, in that case, earthquakes underneath that summit caldera area. But then over to the northwest, where Mauna Loa could not expand northwest because of Hualalai, you'd see that kind of pinch point and you'd have a flare-up spot of earthquakes. Here it's a similar story, but it's Kilauea pushing against Mauna Loa to the northwest. And it looks like that's the catch point as well, right where the volcanoes interact. So really fascinating to see that little interplay of the three earthquakes back and forth, the magnitude. Let's put it back here to our largest ones so I can get them right. We had that 3.1 over there, then a 3.2, and then 3.7. So that little wiggling back and forth, it almost seems like it's doing a little shimmy in some ways. And whatever result that occurred is something fairly complex and hard to describe to you guys. But the adjustment of all the rocks in this area seemed to have relieved that pressure that was building up during that day that led to those triplet earthquakes there. So pretty interesting to note that. It looked like that could have been one of the earthquakes that might have actually broken the structure enough to allow magma to the surface. That wasn't the case in either one of those, or any one of those three. So we're still in that wait and see mode. And so I'll just leave it at that for the earthquakes today, and we'll move on to our monitoring signals, which we will begin with a 2-day tilt. So here's our 2-day tilt. And it's easy to try to look at these little wiggles and think that something major is happening, but the most important thing to look at first is the scale on the left. We're now looking at 0.8 to negative 0.8. So we have had inflation over the last 2 days, but really it's been on the order of 1 microradian or so. So it's certainly a positive increase there with a little bit of variation in between. There have been times where it's risen a little faster and times a little slower, but overall it's been that net gain there. If you zoom it out to the last week, there is that signal, that little tooth mark from the 20th, and you see that following that, we do seem to have what seemed to be a fairly steep rising, and it continued a little bit afterwards as well, fairly steep rising inflationary trend. Seems to have, well, if we average it out here, be a little bit less, right? So it's a little bit shallower line, and we had steeper coming up beforehand. So it's still inflating, but at a slightly slower rate. Earthquakes are down. The tilt rate increase is also down at the same time. So here's back to that 1 month view where that little tooth mark looks a lot smaller right in there. And you can see that corresponds to that day of peak earthquakes right in there. Right? So interestingly, we had a previous little extra ground tilt that increased and decreased off of our baseline here. And that one also led to a little flurry of earthquakes. That's when we had our first pump fake right in there. It seemed like it was getting ready to go pretty quick. And that's really following what we had back on the 16th, and then here at the end of April, a little gap, and then once again here mid-May and a little bit later in May. So we'll see how many times it can go through this cycling and keep making space for itself, which is basically finding ways to do underground. If it can relieve its pressure by pushing the rocks out of the way slightly this way and slightly that way, then it'll do that. And if it's easier to push to the surface through some crack or making a crack, then that's what it'll do instead. And so far it has not come to the surface. So there is the last month of earthquakes, and over that same time frame, here is our SO2 from the summit. Our values are ranging from 50 to 450 tons per day on this graph, so these are all fairly low values. When eruption starts, we expect to see in the thousands to tens of thousands, so we're just looking at the little variations of the background really here. But we did have a little bump that was coincident right in here, where we rose from in the range of 100 tons per day, more or less, to the range of 400 tons per day, more or less. That corresponded to that first flurry of the month here, earlier in May. However, what we have now, looking at this plot, we have 2 low measurements, the most recent one down around 90 tons per day, that was taken yesterday. So the values are low again. After having come up, they seem like they went down. we have a big gap right here, right? So we don't really know if this thing possibly spiked again, corresponding to that earthquakes or not. But in any case, if we even have a little bit of gas increase at the surface, that means the magma is coming pretty shallow for the gas to be able to escape and percolate its way out, whether it's diffusing through that solid rock or finding some path out that the magma can't follow it, that the gas is able to take, but the magma isn't. So interesting to note how all that's corresponding. We don't expect the gas to go up until actually lava's on its way out of the ground or out of the ground already by the time we have the actual measurement synthesized here. So not really a leading indicator, but interesting to note what's happening in correspondence with the earthquakes there. So here in a map zone, this is a plot from the USGS webpage that shows all the small events. That's a little bit further detailed than that main USGS earthquake site. So this is that. There's really two clusters here. It looks like one big figure S, but really there's two clusters here. There's one cluster that's the northwest. That's the Namakani Paio cluster right there. That's that where the summit buildup is pushing northwest and causing interaction there with Mauna Loa. And the second cluster is this one in here, where it has a little tail. It's like a little tau symbol right there, and a little more diffuse to the east. And that's that buildup of magma, presumably in a central area here, pushing out in every direction, and with an interesting upper southwest connector still looking activated here over the last week, as it has for much of the last month here. So we'll have to wait and see what exactly happens. It does seem like there's a lot of activity further south than we sometimes get, just in this one little strand right in there. But really, it could pop up in any path that's easiest to the surface here. So hard to really say that is very meaningful that we see further signs of buildup there. Okay, so that's the map for the last week. We still have earthquakes happening down here in Pahala. These are colored by depth, so these blue indicate a much larger depth. We still have some south flank earthquakes happening over here, right? Because this whole piece of land that's oceanwards of the summit is also getting pushed out, and this one, unlike the northwest, can move. So that movement gets dispersed across all the south flank area all through here, and that's where you see these earthquakes, usually just south of the rift zone there. The rift zone itself is marked by the topography, craters, and cinder cones all through here, and pretty little seismicity all through there overall. So it's really seeming to be contained at the summit, and that's likely the basis of the USGS updates there. So here is the SO2 for the whole year to give it more perspective. 14,000 tons at the top of the scale. 0 is right there. This goes negative for some unknown reason here. Just maybe so you can see the data points better. So here we are, little bump. That little spike was just this little spot on the right, whereas the eruption that happened back in January put us up over 12,000 tons per day. So that's really what I was referring to as far as the gas. You can see that year-long plot corresponds to this one right here. So right here where the earthquakes drop is where you see that increase in gas. And here we are, once again, earthquakes higher than we had it back in January. We're just waiting for it to actually initiate and then do its thing, and then the gas will go up and the earthquakes will go down after that. Whenever that may be, right? It could still be days or weeks away, seeing as it's going through the cycle of every few weeks, going through another ramp up, little flurry of earthquakes, and then it seems to make space for itself and adjust somehow. So how many times can it do that? So we'll have to wait and see, but it seems to be on that few week cycle there. Summit GPS, this is the distance of the caldera north to south. And when it's going up, rising, then the sides are getting further apart. And you can see that we resumed that upward trend here recently. And it looks like we had a little slowdown and then come back up as well. So little variations corresponding to these other minor changes we're seeing on the earthquakes and the tilt at a smaller scale here. So this is just the summit. And if we go back down to the rift zone by Pu'o'o, we see the opposite pattern still. The sides are getting closer together, the distance is getting shorter, the line is going down. Little variations in here as well, because we imagine a south flank adjustment and wiggling is having some effect here. So you see a little bit of this like wiggling kind of stuff. I won't try to trace it any more than that, but this wiggling up and down there is likely some of that effect. But overall, fairly minor compared to the overall trend of downwards. And we now have a tilt meter online at Pu'o'o Crater, and it is also showing deflation, very modest amounts as well, microradians here for the last month, I should say. So those are the monitoring signals here for this week on Kilauea. in a little more detail. I thought we could look in at, this is a 2-day plot I saved from that tooth event. And we see that the tilt offset is something we've seen before in earthquakes. We know that there were 2 earthquakes at the start, and if you look here, this line is a little bit thicker right in there. It's actually 2 lines stacked side by side, so you're actually picking up the first earthquake, goes up, comes back down, and it likely settles somewhere near where it started. The second one goes all the way up, and it settles back here. So the second earthquake, it seems like that one on the northwest part is what really caused this first offset, this jump. You see the trend of inflation doesn't change that much, maybe a little bit less, before those 3 hours later, that next earthquake on the northeast actually pops it. I'm sorry, this was northwest was the first one, northeast here, and then northwest popping it back down. And it comes back to slightly lower inclination than it had prior, pretty close, but that might be some indication that there was some give, that the adjustment occurred right here. So we actually worked to relieve some of the pressure. We didn't just get back to where we started, but a little bit past that. So it wasn't a whole lot though. So since then we've resumed and inflated back past that point. Right, but that's a little bit more detail. The interesting thing there, a little shimmy, like wiggle one side up and the other side up, and then somehow it adjusts again. Okay, so I thought we could do something a little bit more analysis on the last few tilt signals, just because I've been thinking about this a little more. Dan and I have been talking about this a little bit too. So here is the most recent eruption from January 2023, the 1-month tilt plot. And you can see in this case, a lot of deflation, inflation, a general rising trend of tilt, right? We're looking at, in this case, was -5 to +6 or so. So we're looking at over 10 microradians. We're currently now at 14. What I'm really curious about is what does a signal look like right prior to that eruption? So in this case, we can see that it was actually rising, was inflating, and then we have a big earthquake. Eruption begins and goes there, right? So in this case, eruption begins when the tilt is rising. We go back to the one prior to that. Here is the one from September 2021. Also long-term inflation. In this case, we're going from -8-ish to +8, so 16 microradians before we have a big earthquake that sets us upwards, offsets us upwards, and then there's an eruption again, right? So also we were inflating kind of slowly in that case before that actually popped up. So look at one more, and eruption is this one here on the right. And so in this case, you can see we had deflation, inflation events. We had some little wiggles up, little wiggles down. We had some, fairly steep climbs, a little bit less steep climbs, and some kind of flattish. And then in this case, boom, it begins still rising very slowly, inflating, but not really dramatically in that case as well. Now this one that goes back to December 2020 also has, on this side of the graph, an intrusion. When that's the other thing that can happen here. We don't have to have magma actually come to the surface. It could fill some space on the ground and adjust the volcano that way. In fact, you could think of these earthquake patterns and earthquake flurries that we've had over the last month as likely just filling the magma chamber. And there are areas that's getting into that you could consider small scale intrusions. But we're just not calling it that because of the lack of characteristic swarm and the association to that summit area where it seems like it's been filling this entire time. But back to our sim analysis of intrusions. Deflation and inflation cycle is back and forth. In this case, we were actually near the peak of an inflation cycle. And then we have a big intrusion occurs there, big offset, right? So you can see in many of these cases it actually is inflating, but it's not as fast. It can be inflating closer to flat or fast, as you can see in this one graph. But to continue our analysis here is the previous, or the intrusion that followed that, back in August 2021, late August, prior to the September 2021 eruption. And in this case, there is that, let's look at the green line. This is the one that's showing that similar component. It's rising pretty slowly there, but it is rising. And then it ramps up for that intrusion. However, this was a two-stage intrusion. So the second stage coming in right here. And in between the two, you see it's pretty much flat that entire time. So it goes from flat to, okay, here we're going again. And so it can pick up from we've seen now rising, or from rising steeply, not so steeply, or flat. And if I go one more back to the intrusion that occurred in September of last year. So it's in relation to Mauna Loa interacting with Kilauea and Kilauea beginning to shut off. In this case, you see the tilt was pretty flat. It's coming down, a slight little inflation, deflation. It's actually close to the bottom of a deflation cycle. And intrusion happens at the bottom of the deflation cycle, right there. So it's one example where you can actually see it deflating before it actually initiates. So just from the last 6 events here, you can see certainly most of them are occurring during inflation. A couple maybe occur during steep inflation, but you even have one occurring during deflation. So it's really hard to plot a pattern. It's hard to watch a tilt meter to see what's actually happening. Really, the earthquakes are a better indicator when they really flare up, and then the tilt then verifies it for you. If you do see the offset, then you know, okay, well, something did happen there. But it's a little tricky to get everything pieced together there. So there's a little bit more analysis in depth on that tilt signal, since we're all watching that so closely nowadays. All right, so moving on to the gas hazard. We talked about the levels being fairly low there. So we can show you guys the most recent VOG mapping project forecast for VOG dispersal from Kilauea Summit right here. At only 90 tons per day, so not a whole lot of volume. That makes it a fairly limited impact. But you can see that there is effect that occurs around Volcano Village area, a little bit towards the saddle, up towards Mauna Loa's northeast flank, but also down into Ka'u towards Pahala and Ocean View for a little bit of time there, right? And your upper South Kona area as well on the flank. So 90 tons per day is not a huge amount for the volcano, but it would still break all the EPA regulations. And if you live near this, it would still be like living next to a factory that's breaking all the laws. So that's kind of how it feels for those who are nearby, especially those who are sensitive. So I don't want to really diminish that. It's still happening. It's just happening at lower levels than we have experienced in the volcano, because it really can get pretty ridiculous when it erupts, how much gas can come out. So that is the VOG forecast for the next couple of days, and grab from Purple Air showing citizen science monitors around the island, everything in the green presently, confirming that. And the last thing I'd like to check as well is a national park, which is the air quality alert page in Hawaii Volcanoes National Park. And so everything is in the green today. Wind is blowing from the northeast. Plume is going southwest there, mostly offshore, as you can see in this little inset right through here. And as you know, I like to push the chart button and look back at the last couple of days. And so everything is in the green here. Even the volcano area has not had any impact recorded on these graphs, but maybe something will pop up in the next day or two as that forecast shows some of that stuff sweeping around the area there. Of course, it depends how much is puffing out at that exact moment, right? That's just one thing they can't quite predict. It's not necessarily constantly fizzling out at the same rate. It might have some variations as well. So that is our gas. And with that, we can move to our observation, our practice of Kilo on Kilauea. And this week, we have a new video from USGS. And this is an overflight of the summit region. I'll play it for you guys here. I am playing it at 2x speed, so we can move it along a little more quickly and without any chopper sounds. So there is that inner pit, Halemaʻumaʻu crater. There is that hardened crust of lava underneath which there's still all that liquid, and it's still degassing, and you see the gas leaking out through these. This is that western basin. The eastern basin looks a little more quiet, but there is a spot of fume over there on the eastern basin as well as these cracks that surround the perimeter of the crusted crater floor, especially here in the south, seems to be fuming pretty profusely recently. So here we are, coming all the way around. It's quite a lot different than it looked. It's looked over the last 5 years. It's almost up to this ledge on this side. It's almost up to the ledge on this side, but it's currently statically sitting there and maybe cooling just slightly. That's the video. We do have a set of images as well from the overflight. So here it is. The overflight produced a thermal map showing in blue here the areas that are still warm because there's still lava underneath there, but solid on the surface, and not actually showing the yellows and reds that we see for active lava when we do have those maps. A little bit closer in, we do see one spot of red, which is where that west vent pond still sits and glows a little bit right there, right? The one spot we've been looking at that Seems to be a pretty efficient chimney down there, where the prior west vent complex used to effuse lava. So those are the maps. And then we have a couple of images of vibro-sized truck spottings here. So this is Mauna Loa parking lot. Right in here, the truck is, let's see if I can open this and get it a little zoomed in for you guys. Go to the original. And there. So, yeah, there is the truck down in there. It's got some support vehicles around it in the parking lot. A couple of tourist cars there, people watching. This behind it is Pauahi crater in the background there. So that's one. And we have a reverse angle as well. Look at its front. Not up here. Give you guys the original full-scale image and blow it up there. There is a truck once again. And in this view, you can see this is that loop of Mauna Loa parking lot. This is the previous Chain of Craters Road right here, where it got covered in lava. In 1972, flow right through here, and 1974, flow right there. And Mauna Loa itself is off the top of the image as that lava shield, something like that, and farther up that way. That was formed between 1969 and 74 there. So the truck is making its way down that area. That's on a Chain of Craters Road. So we can look here at the page for the vibro size and look at the schedule. Today is the 25th, so we're down on this segment right in here, where they're reporting Ainaho Road to Mauna Ulu, including portions of China Craters Road, portion of the escape road south of Nahuku to Mauna Ulu, portion of China Craters Road between Mauna Ulu and Hilinapali Road, and China Craters Road between Hilinapali and the Puʻupuaʻi parking lot. So all over that southern part of the caldera on China Craters Road, and also closer by to the Puʻupuaʻi area as well. And then the last couple days coming up here will be Crater Rim Drive south of the entrance station to the area north of Kilauea Visitor Center, Old Volcano Road on the village, Haunani Road in the village, and a Wright Road in the village. So this will be the day it's actually in Volcano Village. Will be sometime between the 29th, 30th, and 31st, in case anyone is in the area there. So that's the schedule there, and we'll come back to our photographs. I thought I'd stick that in there since it's more relevant. But we do have some other observations. Here is another static image of that overflight showing those Western Basin, West Vent Pond area right there putting out gas, and then Eastern Basin right through here. That was the most recent eruption site right through there. And still remnant, the central island from that original December 2020 fountain of lava that impacted that standing pond of water, right, and produced this very low density frothy lava that's floated like a cork and risen with the lake the entire last few eruptions that this thing has been filling up. Over 1,200 feet now, this thing has risen up from where it actually formed. Well, pretty impressive. So there's the observations. Here's our image we first started off. Wider view, Mauna Loa behind it, and both volcanoes in a state of quiet here. All right, we saw this video, and we're going to switch to Mauna Loa here pretty soon, but we'll just keep going with the images. There is a Mauna Loa GPS campaign ongoing. Here they are on the summit of Mauna Loa, looking across to Mauna Kea in the background, right up here. And what they do is they find a benchmark, which is an installed metal plate on a rock that they've put in for this exact reason, to then center this instrument over top of it with a laser. And then they let it sit there to collect data so they can get a really good indication of where that ground is presently and where it may have moved from the last survey. So both vertically and horizontally, and by leaving them there for a little while, you get better quality data because you can put in a better average. There's a different setup, different location. Mokuaweo'aweo there in the background. This looks like the 1949 cone over here on the right on the edge. So we're looking kind of to southwest from the north rim of Mauna Loa there. So from this angle, there's probably some eruption that occurs like right in there and then around the back of this hill off in that direction. That's the one that went into that upper southwest rift connector of Mauna Loa, and then the rest of it was in the caldera and off the screen here the other direction. One last one there. Another setup, you can see the actual receiver and then all the instrumentation is inside the box there. So that is the set of images and our observations here. Mostly Kilauea, a little bit Mauna Loa here at the end, but that does conclude our Kilauea segment. Apart from noting that, let's see. Well, we'll do that later. I do have something that is released from USGS. We'll cover that a little bit later. So we'll switch to Mauna Loa. Having seen Mauna Loa images and that they're following up on it back there. And to our top here, tilt over the last month, showing the daily up and downs, overall slow rising tilt. You see in this scale, looks like 3 microradians or so, so that's decent for Mauna Loa. Mauna Loa's got a different set of thresholds because of different configuration, magma being deeper down. So 3 microradians for Mauna Loa is still decent inflation there, but it does not have the levels of earthquakes. We're having earthquakes, this is 6 earthquakes per day. Our peak during the last month here was 9 earthquakes in one day. So overall, very low levels of earthquakes. It can be refilling, but not getting to the point where it's actually cracking or anything like that. It's kind of recovering from the last eruption still. And to put that in perspective, here's the last year. This was pre-eruption, 2022, and here we are now. So very low levels. And even further, the last 5 years, there's 2022, and here we are at very low levels. Right? Even lower than we had for much of the last 5 years building up to the 2022 eruption. So not even really in a build-up stage yet. Very, very low levels. Earthquakes. Where are the earthquakes? Here is a plot from the USGS. Pretty scattered around this southeast flank. Nothing really big in the last week. But we have seen some bigger ones last month, so it's interesting to know how it's still adjusting there. Nothing major, all small kind of stuff. And that's the signals from Mauna Loa. Really not a whole lot to report there. All is calm and well on Mauna Loa. So we'll turn now to our Volcano Watch. And Volcano Watch this week is Legends of Eruptions Past. So in this particular article released today, which is also posted on HawaiiTracker.com, you guys can go and read more detail. I'll highlight a few things here. They're actually focusing more on other areas apart from Hawaii. So let's just follow them along, and then we'll come back to Hawaii in a bit here. So, image of our water lake that existed at Halemaʻumaʻu Summit. We'll come back to that here as well, but that's one of the Hawaiian stories that we can come to. However, this is about the overall field of volcanology, and one important tool that sometimes can be overlooked, the oral history. So long before we were writing books or reading seismographs, our ancestors were recording events in their memories and passing them down through stories, poetry, and song. Today we call them myths, legends, or oral traditions. We can imagine these colorful stories being told for entertainment. These stories, however, are rooted in actual real events, if you know how to look. So they mentioned Hawaiian story, they mentioned the Napu'uapele that we'll talk about here shortly. In other places, not so straightforward. So they're going to actually look at examples from Australia and Iceland. In Australia, they look at the dreaming stories of the Bungandigij, Boandik, my best attempt there. People who tell of a giant named Crate Bull who traveled across southeastern Australia with his family in search of a home. And this is think of it as a volcano spirit, like Pele perhaps, right? Except this is Crate Bull in Australia. So first they settled at Mount Muirhead, dug their cooking oven, or settled in for the night when they were awakened by a shrieking bullen, a bird, warning them of an evil spirit. They fled and built a new cooking oven at Mount Shank. Again, the bullen shrieked and chased the family from their rest, and they settled at Mount Gambier. All was peaceful until one day water rose from the ground and destroyed their cooking fires. They dug their ovens again and again, 4 times, and each time water rose to douse the flames, leaving gaping holes where their ovens once were. Finally, Crate Bull and his family moved one last time and settled for good in a cave on the side of the peak. So that dreaming recalls several eruptions, ending with the formation of 4 crater lakes at the Mara volcano, Mount Gambier in Southeast Australia about 4,500 years ago. So these come from Aboriginal heritage, passed down thousands of years. That's your Australia example. They have one from Iceland, and I just wanted to tell this because I get to talk about Thor for once, right? It's very rare we actually get to talk about Thor in our volcano updates. But here he is, Thor is making an appearance. He's relevant to the volcano for once. It's just a volcano in Iceland. So, passed down orally for hundreds of years before being scribed by Snorri Sturluson is a great duel between a god Thor and a giant Hrungnir. Begins with the pounding hooves of Odin, Thor's father, racing Hrungnir from Jotunheim, land of the giants to Asgard, land of the gods. The gods invite Hrungnir for a feast. Soon he becomes loud and boastful, saying he will kill the gods, challenges Thor to a duel, and they start fighting into the night. At one point, Hrungnir protects himself by standing atop his great stone shield, and thinking Thor would attack him from beneath. Instead, Thor hurls his mighty hammer from above. Thor's hammer collides with Hrungnir's whetstone in midair with a thunderclap, showering the land with sparks and shattered fragments. Thunder and sparks and shattered fragments. As they say, rumbling hooves, bellowing giants and enormous stone shields. Sparks and shattered stone raining from above. Sounds like an eruption, doesn't it? So why just not call it that? Why cloak these events in a flowery language and turn them into myths or legends? Because that's how we remember them for thousands of years. Events fade from memory within a generation or two, but great stories become myths, legends, or traditions, and are remembered far longer. We are wise then to listen to stories that our ancestors passed to us for clues about Earth's history. Next time you come across a tale from long ago, imagine what real events may be hidden in the story. So that's most of it there. I skipped a couple little parts in case you want to go read some more, but just to bring that back to Hawaii, they do mention the stories of and show the image of the Crater Lake there, right? So there's a Volcano Watch article that goes back to January 2020 when we still had that newly emergent water pond in that collapsed pit of Halemaʻumaʻu. There it is. And they note here that at that point in time, there was a first lake of groundwater observed on the crater floor in nearly 200 years. So they looked to Hawaiian chants for mentions of crater lakes before Western contact and whether it was associated with explosive eruptions. For our knowledge, the lake is not mentioned explicitly, but Hawaiians did tell a few stories where Pilihonuamea faced the threat of water drowning her volcanic fires at Kilauea. A few are briefly recounted here. So just a little insert here. You know, we have heard of hints that maybe there are some ponds of water and things on there, but we don't have more detail on that in this article here, so we'll just leave that aside for now. Kīlauea and her older sister Namaka, the oldest of the family, were imbued by different powers. This is the battle between the seas and the volcano there. So the story of Pele Namaka is pretty famous. I won't recount it exactly, but they do clash multiple times with spectacular explosive displays each time lava enters the ocean. Another Pele story involving water features Kamapua'a, the pig deity from Oahu, who traveled to Kilauea to woo Pele and take her for his wife. Pele refuses him, insults him, tries to kill him. Kamapua'a, he gets mad, and he floods the crater with water to put out her fire. Pele's brother hides her fire sticks and reignites the flames. And the story ends either as Pele chasing Kamapua'a to the sea, or as a marriage that doesn't last very long. Another story number 3 here, story of Hi'iaka Ikapuli'opele, Hi'iaka, Pele's younger sister, and Pele itself. This is a story that we've told in the past that recounts the collapse of Kilauea caldera. Right? Hi'iaka comes to Kilauea crater with her new husband Lohi'au, who Pele had tasked Hi'iaka to go and collect for her. So because of that unfaithfulness, Pele puts out a big flow, destroys Hi'iaka's forest, kills Lohi'au, and Hi'iaka goes to retrieve Lohi'au's spirit. And she does that by jumping down onto the crater floor, not finding the spirit, stomping her feet, and then digging down to try to find his body, right? The entire crater of Kilauea was rocked and the cliff walls of Uekuhuna trembled. This is from the epic tale of Hi'iaka Ikapuli'opele, translated by Nogelmeyer. And the first layer of Kilauea cracked open. She looked down, but still not seeing her husband, she stomped away. She continued stomping through several layers without finding her husband's spirit. The described effects of Hi'iaka's repeated stomping to get deeper beneath the crater floor are eerily like the continuous strong shaking of the 2018 collapse events. Hi'iaka finally got down to the 5th layer that was holding back water, which if released would rise and flood the crater, turning Kilauea into a lake and putting out Pele's fires forever. At the last instant, Kilauea was dissuaded from her destructive task and reconciled with her sister. So Hi'iaka was seeking groundwater like appeared in Halemaʻumaʻu in 2020, and that's another analogy of that water there. And I'll leave that one right there and just turn to the final story that they mention, which is a story of Napu'uapele, And this goes back to Westervelt's 1916 book, Hawaiian Legends of Volcanoes, with the two hills on the Ka'u coast that are just above the top of Hawaiian Ocean View Estates. Okay, so I pulled up a map because it's a little hard to visualize. Here is South Hawaii. Ocean View is this area right in here. It probably encompasses a little bit of that right there. Go to the very top of it and look uphill. That area, that double cinder cone that's pretty reddish, that's Halemaʻumaʻu, the pregnant bird up there, right? And so you can see there's the actual trace of that flow. It went down to the ocean to the southwest and reached the ocean in looks like 3 different places right there. Pretty big, wide flow. So this was, at the time of this volcano watch, 1996, just recently completed being redated. They previously thought that it might have been somewhere in the range of 700, 1,000 years old, but they come out with this analysis noting that the date of that flow had to have been about 240 years plus or minus, based on carbon-14 on carbonized wood from beneath lava flows. That puts it around AD 1660, around when that eruption actually happened right then. Right, so the story goes as such. There were 2 chiefs of Kahuku who were in love with a beautiful maiden who had visited their villages, but she had a bad temper and they became suspicious that that was actually Pele. So they decided to spurn her, at which point she turned into a wrathful old woman whose, quote, hair floated out in tangled masses, whose limbs shone as if enwrapped with fire, and whose eyes blazed forth like lightning. When the chiefs ran in terror from Pele, she became enraged and, quote, struck the ground heavily with her feet. And, quote, earthquake swept the land of Kahuku. And, quote, an awful fiery flood broke forth from the underworld and swept down over Kahuku. The terrified chiefs tried to reach the sea by fleeing north, but then a new flow made them turn back south. Just as the chiefs almost reached the sea, Pele threw her arms around her former lovers, and the lifeless bodies of the chiefs are preserved as Napu'u Pele. So they've actually mapped that flow, as I showed you the image right then. This is going back now almost 30 years, yeah. And they note that that flow, the Halemaʻumaʻu flow, must be the same one alluded to in Hawaiian legend. That flow consists of 2 lobes. Mapping shows the southern lobe is older. The refugees fleeing north from the first flow would indeed have been turned back by the later north flow, exactly as told in the legend. The earthquake caused by Pele stamping her feet are a phenomenon which must indeed have preceded the Halemaʻumaʻu eruption, and then the date right there as well. So, by the way, that newly dated flow is one of the largest single flows in the lower southwest rift zone, covering over 100 square kilometers of area, more than 3 times the area of the 84 flow, and it forms about 11 kilometers. Now you're looking at, what's that, about 6 or 7 miles of coastline of Ka'u, from Manuka Bay to Humuhumu Point. And at the time, this is now 30 years old, 1/3 of the subdivisions of the area located on that flow, whose source vents were between 5,400 and 6,400 feet. And in that area, 15 eruptions since 1,500 years ago. So just one more example of a story that is actually referring to a geologic event, and when it happened recently enough that we can tie things together because we can still see everything on the surface, then it's pretty cool to note that as well, right? Or when it reappears like water in Halemaʻumaʻu that hadn't been seen in hundreds of years. So a little extra focus here on oral history today, just because it is the focus of Volcano Watch. And with that, we will turn to our final community section here, and I just have a couple of things in our community update for you guys today. One is for a national park, who is seeking public input on their draft air tour management plan for the Hawaii Volcanoes National Park. And so this is a comment period that runs through June 20th. Not June 16th as previously said, but June 20th is open, so you can go on the park website and find this comment period and where to click and submit comments. But here's the long and short of it. Let's see. Between 2017 and 2019, I'm skipping around here, tent operators reported an average of 11,376 flights per year at the national park. 11,000 flights per year was the average between 2017 and 2019. Right? So they are revising this now to 1,565 air tours per year. Right, so we're looking at only 10% or so of the amount. Maybe a little more than that. So they're cutting the traffic a lot. They're having 3 defined routes. They are designating Wednesdays as quiet technology flights only. So this quiet technology flights is a new thing for Hawaii. It's something that they have trialed at Grand Canyon National Park for almost 20 years now. Because Grand Canyon actually at one point had 100,000 flights per year. So we might think we had it bad here in Hawaii with 11,000, but the Grand Canyon was a huge amount more. That's why they did all the trials there. So apparently successful, and so they have regular tours, regular helicopters like we have here. Those would be between Mondays, and so that would be Mondays and Tuesdays, 10 to 2, and Thursdays, Fridays, and Saturdays from 10 to 2. Otherwise, there are additional 9 to 5 all those days for the quiet technology flights. Wednesdays, QT flights only, also 9 to 5, and no one gets to fly on the Sundays. So quite a lot of cutback on the traffic there. I imagine there's going to be some pushback from the tourism industry, at least the helicopter component of it. However, you'd imagine that everyone who's on the ground would be happier because you want to see things closer on the ground. That leads the on the ground tour companies might have more business possibly there as well. Personally, I live near the national park, and it's a huge blessing to not have that constant air traffic and buzzing. It almost feels like mosquitoes sometimes in the past, where there's so many flying overhead. And Dane, you had a little bit of that 2018 when all the flights were down in Lower Puna, and yeah, it can be quite intrusive depending on what's going on there.
True,
so
right.
That's the long and short of it. There. Go ahead.
One of the things I'm just thinking of immediately is like that giant of a cut in flights. It's like, all right, well, you've priced out everybody that basically local wanted to just go see the thing at that point. That's my immediate reaction to it, is because if the supply is cut by tenfold and the demand is the same, then you can easily get away with charging significantly more for the same flight, just because of demand, right? So yeah. I'm just like, okay, so now we're not going to be able to go up basically anymore. This is what I see. That's what I read on this. And like, all right, so we're not going up anymore because we're going to be priced out. We're not going to be able to secure one of those 1,000 flights, basically. So good luck. Those will just be very rich tourists, essentially, that'll get that privilege. That's what that's my reaction to it.
Yeah, it's a good point. Yeah, and it's interesting to know. I mean, it's really not in a park to determine how the operators sell their flights or what have you. It would be nice if they had some path for the locals to actually see that.
Right.
But as you say, like they're already going to be struggling with this, and it's hard to see them voluntarily cutting it even more. Yeah.
If each company only has, say 100 flights a year to be able to do it, or 200 or 300 or whatever, it's like, how many of those are you going to set aside for charity, essentially?
Yeah. So yeah, if you look at that 1565, you take off. There's basically 6 days a week you're flying. You're looking at, let's take out Wednesdays too. 5 days a week you're flying, so you're looking at about 6 tours a day, really 6 flights a day. And if you had 10 operators before, that means not everyone gets to fly every day already. And so someone's going to have to adapt or,
fly somewhere else, basically.
Fly somewhere else, or yeah,
improve
exactly.
Their marketing and other tours that they can still fly. Because I'm like, those are just going to be top dollar flights because that's where the demand is, especially when something's happening.
Yeah.
Like, I'd be rationing them out until the eruption goes, and then trying to sell them for premiums if I was a helicopter tour company at that point, and that was the game you were laid out in front of me. I'm just saying, we're not in the tourism thing, but just my immediate reaction to that is like, okay, that's what they'll move to, right? That's just.
So these are air tours. I wonder if there's anything different for. I mean, obviously, civil defense and USGS can fly whenever they want and not be restricted by this.
Of course. So
I wonder if you had like a news helicopter or something, if there would be restrictions on that as well. I don't know. So that'd be interesting things to hear back. And
I think I could see a news helicopter maybe getting permission, and being outside of this. It seems like for tourist helicopters, air tours specifically. So I assume the other channels for everything else is normal, but yeah, that's still, we don't have that access right now. We know some people that might, but
Yeah.
That's just
Yeah, it's a huge
how it
cutback.
looks.
Yeah, 10 a.m. to 2 p.m. is a pretty small window as well, right? I mean, imagine
Right.
not getting anything near any kind of dark or sunset, anything like that. So yes, it's really a huge cut. There have been groups in Hawaii Island like HiCop that have been protesting helicopters for decades, really, right? Because especially when flights went to Pu'o'o, it'd come over a lot more neighborhoods up the highway than we do now. So I think a lot of residents are probably happy. A lot of helicopter tourism representatives are probably not happy. So whichever side you fall on, you're welcome to go and comment on the national park with your point of view there.
Yeah, right.
One interesting thing is how they do allow this QT technology for 9 to 5 and also on Wednesdays, right? So I tried to find more on this, and there's not a whole lot, but there is this. I won't play this video, right? But you do have this that they've talked about, the Grand Canyon. This is the all-electric Sunfire aircraft, a 2-seater prototype by Aero Electric Aircraft Corp. Runs on lithium-ion batteries, zero emissions, super quiet compared to its noisy combustible cousins. So this is actually a national park website promoting this, right? This is probably the kind of thing you're talking about. So they're likely trying to incentivize this kind of aircraft.
What's the range on one of those things?
I have no idea. I haven't watched it, but yeah, if you're flying out of Hilo, then I mean, how bad can it really be, right? So
that's the question.
Yeah. I mean, if they're flying around Grand Canyon, I mean, I think the Grand Canyon is probably similar geography as far as where you're landing compared to here.
Look into that at least, right?
Yeah. So one interesting thing is that at the Grand Canyon, they first tried out this quiet flight thing, and now they actually are allowing extra flights for quiet flights only, right? So what happened there is once that this initiative actually seemed to work out a little bit, they're now encouraging more flights so long as they're the quiet flight kind. So they're actually ramping it back up there. So maybe that'll happen here too. It could be that there's a path forward for more flights in the future, so long as they're this quiet flight kind. And I don't know of anything like this on the island right now that's flying towards the volcano.
And it's only a 2-seater, so you have the pilot and then one person that you're taking on that thing. This
is just a prototype, so they're obviously just trying to, they're trying to allow a path, but they're not making it easy, and they're trying to drive innovation there. And obviously, the quiet is important not just for humans, but for the wildlife, and that's their main concern here. And it's a national initiative, been going on 20 years now, Grand Canyon. So I would guess that this is pretty entrenched, this whole thing here. In any case, that is the review for the community input on the air tour from National Park. A couple of final points here. The USGS has noted that their final environmental assessment has a finding of no significant impact for their new Hilo research facility. So they're going to move forward with the project down in Hilo. And that's all I'll say about that. Things will be posted as well, but that's the statement from them. And then one last thing here. There is a new data release set from the USGS, and there's a few different items in here. So one by one. First, colorimeter data for the Summit Water Lake at Kīlauea Volcano, Island, Hawaii 2020. So they're actually using a colorimeter to look at the color of the lake, which had dissolved minerals in it. And they were using that as a monitoring method because that was something they talked about seeing other volcanoes. They can maybe tell something about the content of sulfur, for example, and how much is getting scrubbed by that water table and all of that, right? Which we now know in hindsight was happening there. So they actually did color measurements, and there's all the data released for that. There is also details of the Mauna Loa eruption, December 2022, and this includes sample details and near real-time EDXRF, grain size and grain shape data collected, all in a spreadsheets there. And there is that data set as well. There is another one, which is also lava samples, but in this case, back to the Pu'o'o and Summit Lava Lake eruptions of Hawaii. So this is kind of a catch-up data set right here. Back to Pu'o'o and Kīlauea Summit. Similar kind of thing where they collected samples and had measurements on them all on a table. And then I think this is the last one down here. Yeah, last one goes back even further, even extra catching up back from December of 2000, when I was still a HVO volunteer. And at that point, they were installing 3 no-tilt meters on Mauna Loa. And as they installed those tilt meters, they had to drill down to a depth of over 100 meters. So we're talking about 300 to 400 feet-ish, more or less, beneath the ground for those tilt meter installations. And as they drilled the holes, they cored them and recovered the core and logged the rocks that they pulled out of there. So that now you could go and analyze how those rocks, what the sequence of lava flows and chemistries of those rocks are from those locations. So where something's not exposed at the surface, which Mauna Loa is all pretty young, so there's a lot of stuff that's not at the surface anymore, then you can look at these cores, for example, to get more data that way. So data is also linked there as well. So none of this is really that useful to show you guys in its raw form. Just point out that the data exists out there, and we'll see what comes from it in the future here. But that wraps up the community releases and updates from the USGS and a national park. And with that, Dane, we could turn to our thank yous when you are ready.
All right. Yeah. I want to thank everybody that tuned in today. We really rely on the viewers like you to help get this information out there. We don't have advertising budget, so it's really word of mouth, the likes, the shares, the subscriptions, all that stuff. Helps with the algorithm. I don't know if you could hear the dog going off there, but yeah, we also like to thank the County of Hawaii through the Vivite Grant Program. They've helped us for the past year being able to provide this type of content, as well as their written and short videos that we do on Hawaii Tracker, and we really appreciate that. We also had a longtime supporter come through, Scudget Ed, with a $20. Says, thanks guys, go have a beer when you're finished. Mahalo. We also had a few questions come through if you want to take those. I know it's been a little while since we've had some questions.
Yeah, let's discuss some questions.
All right. Matt asks, do the locations of the earthquakes around the summit give any indication of where the eruption might occur? Other than just the summit, or the vaguely around the summit. Is there anything more than that?
The short answer is what we've seen so far is really no. I mean, it's easy to say in hindsight. If we were to go back and after eruption happens, say, okay, what happened in this area? I mean, I'm seeing more activity here to the south, but it's really about where the weakest point to the surface happens to be, and that could be really anywhere. And so we're seeing where it's building up underground, but where it pops upwards is a whole different story. And it may be related to here, but if I had to bet, I'd say that the zone of densest concentration is right there in the middle, right at Halemaʻumaʻu, and so I'd say the most likely place is right in the middle there. And then you obviously have a big, it's still possible all through here. I mean, possibly, all through there, but that's more or less the area that I would draw anywhere in where potentially where it could go. We have seen in the past that there have been migrations of seismicity. So let's say that we'd see earthquakes moving, and then when we move to over here, and suddenly we had earthquakes over here, then that might change our prognosis there at that point in time. But really, it's the earthquakes that kind of come up right before the event that tell you that, okay, it's coming, and it's coming at that point, and it's coming at that point very soon. You don't get a whole lot of warning of that actual breakage point ahead of time, usually only once it's underway breaking right then. So it's a good question. Maybe in hindsight we could answer it, oh, like that looks like it was the buildup, but ahead of time it's really hard to really say anything more conclusive than that.
All right. Victoria asks, isn't 200 the magic number roughly we're looking for a precursor in terms of earthquakes, meaning earthquakes greater than 200 and it's basically on its way?
So earthquakes per week or per day here. This is the 200 value here. We exceeded 200 on the 20th there, right? And this is actually, this plot is referring to all the ones on the map, which I just showed you guys, which is the summit ones, but it also includes the flank. It also includes Pahala down in here, right? So that 200 is for that whole region. That's kind of the first thing to mention. And the second thing to mention is that we are reaching higher levels now than we have in the past, and especially if we go to our year-long plot, something like this, where we note, okay, here's 2023 January, and here's what's happening now, and we're at higher levels. So what's obvious is the conditions at both times are different, right? The volcano has changed how it's configured underground and how it's, think of it as how it's stuck together, or what parts are moving or wiggling and which parts aren't since then, right? So it's able to apparently build greater pressure now than it had previously. Right? So previously, it found a path to the surface more easily. It had only been, in that case, 1 month since the last eruption had actually ended. It was actually eruption, you can't tell right here from this plot, but the eruption had ended in the beginning of December of 2022. And so it wasn't long afterwards that it popped back up, and maybe that's why it didn't pressurize quite as much, and the pathway wasn't quite as blocked in, right? Now it seems like it's pretty well clogged up in there, and it's putting more pressure. What the breaking point is, that's really anyone's guess, right? I mean, it could be that 200 earthquakes per day in a summit region, for example, but it could be 300 if the dynamics have changed, if magma's gone and filled in more areas and somehow allowed it to accumulate more pressure in that area, then it doesn't have to necessarily break at a certain exact number. That number can change over time, right? So that's the tricky thing about it, is the conditions are always changing in between eruptions. There's no baseline you can compare from one to the other every single time. Sometimes you'll look at it and be like, oh, look, it hit the same point and it failed at the exact same point, so nothing changed in between. But that's more unusual than something actually did change in between, and now it's going to break at a slightly different level, different threshold than it had before. So I think that's the best discussion I can give of that. It's not a conclusive answer, but maybe there's not exactly a magic number that you know ahead of time. Maybe the best way to put it there. Go on, Dana. Am I losing you?
Yeah, that we had a lag spike there, at the end of your answer.
All right.
And I think we're back. All right. Yep. I think we just have one more quick question, and I was able to try and answer this one in chat, but showed the graphic at least. Desiree asked, just wondering about how much the crater floor has recovered since it collapsed in 2018.
I don't have the exact number here, but let me see if I can pull up the map.
It was like February something 20. I don't know how I closed it.
Yeah,
there it is. I'll throw it in chat.
Let me pull this in here. Kilauea maps page, throw maps, May the 14th. And that's February, you said, huh?
Yeah, it's just I copied and pasted you the link.
Not want to cooperate for me.
Oh yeah, you got to click the thing. It's not written. You got to click. There's like a at the top. There's like a broken looking image link, and you got to click that. It's the USGS site. There's just expect bugs and lag
Yeah,
and
it's not working right there. Somewhere I have this image on my computer, but I don't know how fast I can find it here. Let's see. Back to February.
Yeah, now it's just throwing errors. So okay, good on you, USGS website. It tries,
Yeah.
you know.
You don't happen to have the image, do you?
Yeah, I can throw you the image.
I'm looking, but I just have so many files.
Yeah, it's on its way.
All right, so here we go. Finally, Desiree, here is your answer. There's the map, the cross section is down here. All right, so after collapse, the depth was 1640 feet above sea level there. And post 2023, we filled 1,243 feet above that. 379 meters, so that's the answer there. We're not quite back to the previous level, so if you're wondering how far it was to recover, that's the pre-2018 collapse level. But to get to that, we're gonna have to fill in all this area over to the right as well, and so that's why it's so much longer before it actually reach that level, right? It's gonna refill and fill this inner pit, and then it's gonna spread out along that next ledge for refilling. It's got a long way to go still. So I think I calculated something like it's recovered maybe over 70% of its depth, but maybe only 20% of its volume, more or less. I haven't got the number right in front of me there, but that's ballpark-ish. So that's hopefully that answers your question, Desiree. Mahalo.
All right. Well, that does it for questions this week. Appreciate everybody that tuned in. We will be back next week, 5 p.m. Hawaii Standard Time, unless, Kilauea wakes up. Then we will go live and try and cover that. Expecting to try and do something with 2 pineapples, but, we've kind of been on standby for, it feels like a month now, with a prime volcano, just waiting for it to finally get to the surface. It keeps finding that room underneath, keeps making adjustments and buying time, and eventually that time will run out, and we will have another eruption. The views should be really good on this one. That's the thing I'm looking forward to on this is, it's been getting up there just to the right level type thing, so we can actually see it from multiple angles. And once it goes, should be quite spectacular.
Yeah, presuming it happens in the middle, then it'll be really good views, and we'll just see if it doesn't. It'll probably still be good views because you can see a long ways in that way. So we'll have to wait and see what happens there. So yeah, for sure next Thursday, right, Dane? Possibly before then if we have an eruption, but if we don't have an eruption, we may actually come in with another stream here on Monday or Tuesday next week. Something a little extra, a little bonus. We're not quite sure what it's going to be quite yet, but do keep your eye out for that. We'll likely add another one in here. Special edition at the end of the month if there's not an eruption before next week.
Yep.
So probably two next week.
Hopefully there's an eruption. Just hopefully there's something going, some action, right? I know there's a lot of people just like anticipating, waiting. So it'd be nice to be able to get the show on the road type of thing. But we'll wait and see how it goes, what happens.
Yeah, nothing we can do except wait and see. So yeah, that's it for this week. Anything else, Dane?
Nope, that'll do it for me. Thank you, everyone.
Well, mahalo, everybody. So from Hawaii Tracker, he's Dane DuPont. I'm Philip Ong, and until next week,